First question for today is Davis recorded in this table how far he could throw balls of different weights. He modeled the data set with a linear best fit function. And as you guys have already probably picked up, I'm going to overtalk this a little bit. Linear best fit function mean that this is going to look like a scatter plot. So it's not perfectly linear. And then from there, as soon as you see that, you need to find the calculator. Whether it be your TI-84 or if you like doing it on Desmos better, that's fine. Whatever. We now have to find. This means find a linear rule, find a line. Rule is the word I've had a lot of Math 1 kids get really frustrated with if they happen to use that. Write the rule, write the equation, find a line. Those are all the different ways. But ultimately, as soon as you see linear best fit function, unless they give you an equation, you're going to have to use it and find your line. The question they're asking is approximately how far should he expect to throw a ball that weighs 12 pounds? That 12 is very important. Since we're going to find that, we need the line of best fit, and then we're going to plug in. So these are the actual weight of balls and actual distance. We're going to make a rule that's going to help us predict the future if that pattern stays. So if we were to do this in your TI-84, which I think is the easiest, less to memorize. So you're going to go to oh, that's not right. I'm sorry. Stat, edit. Mine has stuff in it. L1 is your X values. So 1, enter, 3, enter, 5, enter, 10, enter. You don't want to do like commas. You have to hit enter so it'll go down. Again, all this might be a little bit repetitive and you've heard it before, but we got to remember it on the last day. And I don't know if we touch our calculators daily. So Y values in your L2. Now we're going to hit stat again. We're going to right over to count. 1 bar stat is where you get your 5-number summary, your mean, your median, and all that good fun stuff. We're going to go down to linear regression. Now, I do want to call out, just because the more you can see it and the more you look around, the better. We will start doing quadratic soon, quadratic regression. For future math classes, you got a cubic regression. If you go down to 0, that's where you find your exponential regression. That you are required to use or will be expected to be able to use. So 4 and 0 are probably the most used in questions for EOC. Linear, quadratic, and exponential are all fair game. I've seen more linear, a few exponential, not very many quadratics. But again, the only difference is that you would use 4, 5 versus 0, whichever one we're looking for. In this case, we're looking for a linear regression. Depending on your calculators, how many times you're going to have to hit enter. But ultimately, you want to get down to calculate. Hit enter. And this is y equals, this is our mx plus b, but they just happen to use a instead of m. And we're going to use it as is. So we're going to do -5. I like to go 2 places because that's pretty accurate. X, -5.25x, plus 74.94. Likely, if this was an EOC questions, it would help you and tell you how many places to round. So if it wants the 10th, that means we want 1 place. 100ths is 2 places. Thousandths is 3 places. It's usually one of those 3. Now that we have this rule, you can either write it out. Let me move my calculator. My hand's in the way. And then plug in your 12. And then just plug this in Desmos, plug it in your calculator on your home screen. Or if it happens to be a multi-part question and they're asking for change or something good fun like that, if you go to your y equals and we do our -5.25x, which is underneath mode, plus 74.94, because that's our rule. If I hit second graph, I now can see all the outputs for every input without having to put them each in individually. Like if it said 12 and then there was a part B and it said, what about 15? Or maybe it said, what is the difference in the distance between a 15-pound ball and a 12-pound ball? Then if you were on this screen, you could see them without having to do that longhand math very often. Okay, so 12 is 1194. So our answer should be 1194 if we're being super accurate. That word approximately is really important. Sometimes that kind of blows everybody's mind. That just means close enough. So obviously 11.94 is not close to 6. It's not close to 7. And it's way too small for 20. Because again, I always think of things as money. $11.94. Your parents are probably going to hand you $12 if they owe you money. Okay? So that's line of best fit. Now this guy, this is exactly what I was talking about. So this one says the table shows the average salary of professional baseball players X years after 2000, which approximate, so again, it's not going to be super accurate. It's going to be approximate. Exponential function. Exponential function models the salary. So again, we're going to go to our stat. We're going to go to edit. Then we're going to hit stat again after we put in our data. And then we're going to write over to calc. And then we're going to go to 0. 5 is quadratic. 0. To get an exponential function. So we're doing the exact same thing we just did. It's just not linear anymore. So we're going to go to stat, enter edit. And if I need to slow down, if you want to go open your TI-84 app that you downloaded, I can slow down and allow you that opportunity. You just got to let me know. So 3. Again, the more you do it, the more likely you are to remember your keystrokes and where things are. Stat, graph, y equals math and mode are where most of the things we use are. Most of them, unless you want to start messing with the size of your window. If you're looking for graph, at that point, I would probably go to Desmos. Your graphs are a lot easier to read in Desmos than they are in our calculators because they're kind of small. So 89, 118. Also, make sure to double check, because if you do all the math and you punch all the right buttons and you do all the things and you put 117 instead of 118, your answer is really wrong and you did the hard part correct. You just made a mistake before you even got to that part. So you do want to follow up and make sure those numbers are correct, especially on EOC day, because every question counts. Again, 16-ish correct and you pass. Everything else after that is just gravy or icing on the cake. And the more points you get, the better. So what am I going to click next, guys? Which button? Do you remember? We just said it a little while ago. Yep, stat. And then somebody else tell me what am I going to do after that. It's on the screen too, so maybe you can see it. After I hit stat, what will I hit next? Somebody tell me. Oh, close. Not quite. You're good, but not quite. Not quite. Got to do one more thing before we start doing that. Just for fun, if I hit 4 right now, it would say clear list, and then I would take everything out of our list. So if I hit edit again, I'm looking at my list. We already did that, right? So yeah, there we go. I see it. Stat, calc. So right over to calc. Looking at those options, 4 would have been a linear regression. So for the question we just previously did, perfect. But we need an exponential function. So we want to go to 0, exactly. And you can either arrow down or you can push the number 0, and it'll see, like you'll see X regression, the EXP regression on the top. You're just entering down until it finalizes that calculate, because then you're telling you want it to do it. A times B raised to the X, so 63. All of our answer choices are whole numbers, so we'll just leave off the decimals for now. So 63 A times B raised to the X power. That X in the exponent is why this is an exponential function. And that's 1.11. 2 after that 1 leaves it a 1. And again, I'm just going off looking at my answer choices. They have 2 decimal places in the B spot, so that's good. That apparently is where they want them to be. So at that rate, we have an answer, and it should be A. All right, so one more time. I'm going to hit, how am I going to start a regression, whether it be linear, quadratic, or a rule, or a model, a function that models? What's the first calculator button you're going to push? Stat, right? All right, and I'm pushing them with you so you're paying attention. And then the first thing I'm going to do is hit, what am I going to hit next? Edit. Good. I'm going to hit enter. And I'm going to put in my L1 and my L2. Oh, close. So I have to input my data first. My data is now inputted. So which button am I going to push now? What's the next button to push? Stat again, right? And then, Elijah, where am I going? Right over to calc. Yep. And then if I want a linear regression, which number will I use? Good. 4. If I want a exponential regression or exponential function, exponential rule, which number would I use? Good. 0. And if you panic and you get here, I mean, take some time and look at them, read them. So we got X right there, 0. All right, cool. We'll do a lot more of that before the end. But the more we can talk about it, the more you can remember it, the better. Word problem. So this guy is about probably realistically an 8th grade level word problem. But it is very likely to have one like this on calculator inactive. So no calculator. Which, to be honest, the calculator is not going to help you much here. One sentence at a time. I always tell most students, especially EOC, read the very last. Like, what is the question? So looking, not all the fluff, not the whole question, like number 1, and read the whole thing. I mean, what do they want to know? We need to know what they want to know first and foremost. In this question, this problem, I should say, I guess is probably a better word for it. What do they want to know? What do they want to know? Like, this problem has a lot of words. You know, like we hate it because there's all the words. And it's all, oh, I got to read it all. I got to think through it, blah, blah, blah. Right. What I'm saying is, instead of reading all that first, like starting at the top and reading to the bottom like you would a normal question, and like sometimes you would read a book, instead go and see, what are we looking for first? Because if you read that one time and then you read it a second time, you're less apt to jump too fast if it happened to be a multiple choice question and you find an answer that you stumbled into that may or may not be what they're actually talking about. So how old are William and Charmaine is what we want to know. Okay. Periods. So your punctuation matters. I feel like we just crossed into English class, guys. Hold on to your britches. I'm not good at it. So William is. What is another word for is in math? Like, what does is mean? Like an operational, like a symbol. Equals. Good. Equals is. So William, and I like to use the letters of the names because it helps me keep them separate, is 3 years older than Charmaine. 3 years older means we're going to add, subtract, multiply, or divide. Good. We're going to add, right? So 3 years older than Charmaine. So we're going to use a C for Charmaine, and we're going to add 3. So that's William is 3 years older than Charmaine as an equation. Perfect. First one's down. Okay, we're going to look at this second sentence. The sum, which means we're going to do what operation? Add. Good. So we're going to add the sum of 3 times Charmaine's age. So what operation does 3 times mean? The word times means, good, multiply. That means we're going to multiply. So 3 times Charmaine, so we're going to do 3 times C. And, so we're adding it, sum, 2 times Williams. And we said times is multiplication. So 2 times Williams is, and we said is the same thing as equals, good, 76. We have a system of equations right now. This is like those old school, the ones where we're graphing them in a calculator. Again, this is likely not to be a calculator active question just because the numbers are so small. Now we need to find out how old are William and Charmaine. So we have to solve for W and we have to solve for C. That first equation, W is. I would start there and use substitution because I have a W right here that I can replace with C plus 3 because W is C plus 3 and the W just goes away because we just used it. So we have our 2 equals 76, 3C, and we add it together. Operationally, so we're thinking orders of operations, PEMDAS, depending on who taught it to you, which way you remember it. What are we going to do first? Solving this equation, what are we going to do first? Parentheses. Eli, let's see. We'll see. Okay, we'll see what we can get. We'll see if you're right. Let's check it. Let's do the math just for fun. Said nobody ever, right? 3C. So 2 times C is going to give me plus 2C. And then 2 times 3 is going to give me 6 equals 76. From here, you know me, I'm going to put my line of great divide down there so I don't get anything mixed up. What would you do next? Combine like terms on one side, right? Good, good, good. Right, are you alive out there, bud? So we're going to combine like terms with our 3C and our 2C. And we end up with 5C. Plus 6 equals 76. We want to solve for C in this case because that's the only variable we have. What's on the side with C outside of our box that we could move right now, and how would we move it? We're going to subtract 6 from both sides. Good. Subtract 6, subtract 6. And we subtracted 6 because that makes this a 0 in this side and moves it over, right? So 5C is now equal to 70. What operation is 5C? We're going to divide to undo multiplication, right? So we're going to divide to undo multiplication. Good job. So we're going to divide by 5 on both sides. So C equals, you guys tell me. Good. So again, that's the reason I use C and W and I use the letters of their name, because now I know that Charmaine is 14. And if I know that Charmaine is 14, I know my first one says William is Charmaine plus 3, right? So 14 plus 3 is going to give us, good job, 17. So William is 17. Charmaine is 14. And Eli, you weren't wrong in the idea of like trying to do it through logic, because I have found, and I say this in like a loving way, in middle school, the quality of problems they gave you with this style were easy enough that you could logic through it and kind of make your table and work backwards, and you could do it in your brain without making equations. My warning to you is that in Math 1 level, as I've said, the math is the same. They look like the same kind of thing you did. They just spin it just a little harder where you have to do the math. Unfortunately, it's not as easy. Not every single time. Some of you guys can get your brains wrapped around it and you can move around and you can still do them through trial and error or through logic or making a table and just counting down. But if we can practice right in the equations, you'll save yourself a ton of time. You do have 4 hours on your EOC. There will be someone inevitably that's there that will take it. So there's no reason to rush through it at all. But we want to use our time because, like I said, this is sort of just a slightly amped up 8th grade problem. You're going to have quadratics and some things that you haven't done as much that are much more Math 1, high school level problems that deserve your time. So if we can get to where we can write these equations and solve them appropriately, these systems appropriately in one foul swoop, it'll save time. And time is always good. All right. Hopefully you can see this guy. It looks a little blurry. A graph is shown below. Which line is parallel? As soon as I see the word parallel at this point, I feel like we talk about it almost every class. What do we think? What should we be thinking at this point? Like, jumps to the top of our brain. Lines are parallel. Same slope. Good. Same slope. What's a different word? What's another word for slope? Just for the sake of vocabulary review. Ooh, close, but not quite. Yep, okay. So we got the y equals mx plus b. And so we're going to say m is also slope. But how about vocabulary they would use like in a word problem or in a question? Like another word for slope. Got any more? Starts with an R. There's a couple of them actually that starts with R. Rate of change. That's the good one. Rate of change is huge. So rate of change. If you don't already have that one in your brain, you want to write it down. Rate of change. Rate of change is constant when we're talking about linear functions by addition or subtraction. So it's going to add every time. Like if you're making your table, your y values are going to increase at a constant rate by addition or subtraction. In addition being a positive function, subtraction being a negative function. So rate of change by addition or subtraction. There's one more. That's a good one. It's just a good vocabulary word, and that's coefficient of x as far as word problems and very like high school EOC style questions where you might freeze because it's not the word slope that we're used to. Instead, they use rate of change or coefficient of x. And then don't forget, this is also our rise over run. So just like when you see parallel, I want you to think same slope. When you see slope, ideally in a graph, you want to think rise over run. So we got to figure out the slope of our line here. You want to find good points. If it crosses on the axes, whether it be the x or the y, those are really good points every time. And some of you are going to be better at finding the good points than others, but definitely your intercepts. So this is, and again, just y, we're just doing vocabulary here. Y-intercept. This is our x-intercept because it's where it touches the x-axis. And then the y-intercept is where it touches the y-axis. And if I count up, that's 4. And then 2 to the left is the way I counted. Or you can go 2 to the right and down 4. So it's rise. And it's negative. And the negative can go at the top or the bottom. Am I good to leave that negative 4 over 2? No, we want to always reduce, right? So this is going to be negative 2 over 1. And that is just so you can see it in case that doesn't make sense. Here it is here. Down 2 over 1, down 2 over 1, down 2 over 1. Also, something I've called out, you don't want to count one set of slope, like one stair. Like if you make a staircase, you want to have at least 3, just to double check that you're not picking something that looks like a good intersection, but it's not. It's an oops. So you want to make sure you get 3 good counts all the way through. Now, if this is calculator active, I would stop here and I would go put all of these in Desmos and find the one that has a y-intercept at 4, because that's 0, positive 4, and a slope of a negative 2 over 1. So this graph equation is y equals a negative 2x plus 4. Because it started at the y-intercept, your starting point is always the value where it starts on the y-intercept. And then your slope, obviously your m value is whatever you count the rise over run. The problem is our answer choices are in standard form. They're not in slope-intercept form. So the x and y is on one side. If I look at this first guy, I feel like we just did this problem not too many days ago. How do I move that negative 2x over there? So I got y equals, and I have a 5 and a negative 2x. I'm going to add 2x, right? Now, hopefully when you see that positive 5, you already know this is not the answer because our y-intercept is at a 4. So it's definitely not A. We're going to make our negative 2y. I need to move that x. How am I going to move that x over? It's a positive x. We're going to subtract x. Good. So I got negative 2y equals a negative x plus 6 when I move the x over by subtraction. Is y by itself at this point yet? No, right? We got a negative 2 on there. So how are we going to get that negative 2 off? Good. We're going to divide. What are we going to divide by? Yes. We're getting it. Woohoo! So negative 2, negative 2. Then negative x and the negative 2 is going to give us a positive 1/2 x. And then 6 divided by a negative 2 gives us what? What's 6 divided by a negative 2? Yeah, negative 3. All right, we're nailing it. I like it. But that's still not the one we need, right? So that's no good. Hang in there, guys. 2 more. All right, so we got our y, our great divide. We're moving this as a 4x if you can't see it. Positive 4x. How am I going to move that positive 4x? We're going to subtract 4x. Good. Hopefully we're starting to see a pattern in this isolating y. I'm putting in slope-intercept form. So 4 minus 4x. And we're not combining those because one has an x and one does not, right? And we're shooting for y equals mx plus b, and we want to be able to find our slope and our y-intercept. Is y by itself in this one yet? Nope. Good. We're going to divide by negative 2 again. And so that's going to give us something. Oh, I'm crossing these out. We're not looking for the same one. We're looking for one that's parallel. Uh-oh. We might have to back up. We're looking for one that's parallel. This is why I said read the question first, because I've learned where I mess up. Doesn't mean that you will always mess up there, but I have found that we all are human and we mess up in the same places. So disregard my x's. We'll come back. So negative 4x moved over, divided by 2. We now have a positive y equals a negative 2 plus 2x. Because that negative 4 divided by a negative 2 gets a positive 2x. 2y, we're going to subtract 4x again. So 2y equals 10 minus 4x. What am I going to do here? Divide by, it's a positive 2y equals 10 minus 4x. We're going to divide by a positive 2. Good. And I also just found a mistake in my math that y'all didn't call me on. Don't you want to remind the teacher she's not perfect as much as possible? So divide by 2. 10 divided by 2 is 5. Negative 4 divided by 2 is going to be a negative 2x. So if we want to know one that's parallel, that means we have to find the same slope. And we've got that negative 2 as our slope in the line that's graphed, right? So if we look down here, this one says negative 2. But that negative 2x, as we moved it over to the right, that should have become a positive 2x. I'm pretty sure that's what we said, and I just wrote it wrong, but I'm not 100%. So negative 2x, we want to add it to the other side to get it to the other side. So that's a positive 2. So close, opposite, so not the same, not reciprocal, so not perpendicular. We've got a positive 1/2, which is our opposite in reciprocal. So again, going a little outside of the question, but opposite reciprocal is what kind of line? Do you remember? So same slope as parallel. What kind of lines are opposite and reciprocal? Perpendicular. Good. So because 1/2 is the opposite, so it's positive, and it flipped, the negative 2 over 1 became a positive 1 over 2. That's perpendicular. Then we've got a positive 2x here. Again, not good. And then our answer is going to be D. Because we were looking for that negative 2x, the same slope. All right, midpoint. We did it last week, so it's kind of new. But these are great questions too. Unfortunately, they are very EOC-like. And I don't know how you feel about it, but I've had a lot of students that when they see a question with this many words, they start getting real frustrated because there's just words. One step at a time. Take your time. Use graph paper. This one I would not necessarily use Desmos. I feel like sometimes putting it on paper, like hand to paper, is very helpful, like Maddie said. So let's graph these guys. So Sarah's house is located at 7, negative 2. The first number is the x value or the y value? Good. So that means I'm going to go up and down first or left and right first? Ooh, close. So this is our x value. Which direction does the x-axis go in? Left and right. So we're going to go left and right first. So we're going to go to 7. And then it's negative 2. So that's our y value. So then we're going to go down 2. And sorry if it's probably too easy to make it. It's so easy it makes it a hard question that I'm asking. So I'm just making sure. Sorry. I'm making sure that we know that when you see 7, negative 2, because the number of freshman math students I've seen go up 7 and to the left 2 is not good. Because again, that's not, like, you can tell me that 7's your x value and then we go on the wrong direction. So that's where my questions are coming from right now. Is just making sure that we're clear on how to graph and put it on graph paper. All right, so we've got Sarah's house. Mandy's house is 3, 5. So I'm going to go to the right 3 and up 5. That's Mandy's house. Everybody caught up with me now? Your head's not exploded yet? We only got 2 more, I promise. This is it. Okay, so right 3, up 5, because 3, 5. Cameron's house is exactly halfway between Sarah and Mandy's house. Now, you guys didn't say one way or the other last week. Do you prefer graphing? Or do you prefer algebraic for midpoint? Like using a formula. You want to calculate it or you want to graph it? All right, cool. So that means I need to find halfway between here and here. So I'm going to go up, see how many it is total. And that's going to be 1, 2, 3, 4, 5, 6, 7. So to get from 3 to negative, no, I'm sorry, to get to 5 to negative 2 is 7 movements, right? And then we're going to come over 1, 2, 3, 4. So it's over 4. And again, remember if you're doing it algebraically, because I now see that some people said algebraically as well, it's x plus x over 2, y plus y over 2. So 5 plus a negative 2. What am I doing? Yeah. 5 plus a negative 2. That's where we're at right now. And then we've got 7 plus 3. And then we're going to divide those by 2 in a minute. Well, what's half of 7? What is half of 7? If you have $7 and you got to give half of it back to your parents, how much do you have to give them? Good, $3.50, right? 3.5. So 1, 2, 3.5, which is right here. I got a half, 1, 2, 3, perfect. And what's a half of 4? 2. So we're going to go in and get our half 2. And then if I draw, come all the way back to where my line is. Trying to use colors where you can see it, but not mess up the whole graph. So I'm coming down and I'm coming in. This is going to be Cameron's house. And that's about 5 at 1 point and 1.5. So 5 and 1.5. There's 5 down here. I'm sure the numbers are hard to see on my paper. Sorry. 5 and then up 1.5. Then the next step, the next bullet point says Kayla's house is exactly halfway between Cameron's and Mandy's. Now, trust me, if you're not labeling, that's too many steps and you've lost it. So make sure you're putting like the letters of their names or you're writing their names fully out. Or if you are even using it in Desmos, that you are putting the labels on those points, because otherwise you will accidentally grab the numbers you like the best instead of the numbers that need to be used. And so in this case, it's between Cameron and Mandy. So we're now just looking at this line and finding that midpoint. So we're going to count up again. So it's a half, 1, 2, 3, which is not really fun, right? And then over 2. So it's a half up, 1, 2, 3. So 3.5 up, but over 2. What's half of 2? 1, right? Okay, so that's good. So we know we're going to go this direction down that line because that's in the middle of those 2. And then half of 3.5 is going to be about 1 3/4. So about 1, because if you had $3.50 and you start thinking about you had quarters in your pocket and you got to split it, so it's going to be about $1.75. So 1 full one, and then just about, and then we have it here. And this question was multiple choice. I just didn't copy over the answer choices. So usually if it's going to be decimals, they will give you, like any kind of weird, could get funky decimals, they usually will give you a multiple choice option. So it looks like maybe 4. 4 is our x value. We go up here. It's 1, 2, 3. And we'll call it 3.25. So 3.25. Do not slip the 0.25 versus 0.75 versus 0.5 at the moment. Just understand the process of how we got there. Don't worry about where we're standing at the moment, because this is an EOC question, so these are the harder of them. So don't shut down on me. Hang in there. The process is what we're trying to figure out right now, and make sure we're comfortable with the process, because there's equally likely a chance that you get one and it's a whole number. Okay? Oh man, I didn't mean for us to go this long. I'm sorry, guys. One more question. What is the midpoint of the shortest side of a triangle? What do you think the first thing you should do is? Yep. Graph the points. And the reason I ask that is because there's not going to be a graph shown. you're going to have to grab your graph paper, or you're going to have to go grab Desmos and do it. Again, these with just coordinates, I would use graph paper because you can attach the dots or connect the dots. Desmos, there's not a way to do that without a lot of work. So 1, 1, and then I've got 1, 5, and then 7, 1. All of these are the 3 sides of a triangle. It says, what is the midpoint of the shortest side? Now, likely, you can look at this and figure out which one the shortest side is, and you could just find the midpoint of there. But just for conversations, because again, we're learning processes right now. The diagonal line, the hypotenuse of this right triangle, because this is a right triangle and that's our hypotenuse, you would want to find the distance of that one using Pythagorean theorem. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Which you could even count the bottom because they're going to reflect over each other. So that's a squared plus b squared equals c squared. 4 squared plus 6 squared equals c squared. What's 4 squared, guys? Good, 16. What's 6 squared? Lovely. Good job. C squared. So 16 plus 36 is going to give me what? Good. 52 equals c squared. That is the square root of 52 for the length because c squared is not just that side. So square root of 52, we're going to leave it written that way just because that's an ugly decimal. 5 times 5 is 25, so we know it's going to be somewhere around 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, so it'll be 7 and some decimal, probably. I did that fast, but obviously you could use a calculator. These numbers, though, probably fair that they would not let you because they're pretty small. Midpoint of this line here, or the length of this line is 1 to 7, so it's 6 units, and this is 4 units. And like I said, 7 times 7 is 49, and that's smaller. So this number is going to be greater than 7, for sure. Whatever it is, it's greater than 7. So it's our longer side, mid side, and our shorter side. So the midpoint, this is 4, 2, 3, 4. If I wanted to find the middle of 4, how many will I go up or down? Or what's half of 4? 2, right? So I'm going to go 1, 2, midpoint. And that's 1, 3 for a coordinate. And there's our answer. I think a lot of people see these style problems and the idea of picking up a pencil or pen and grabbing a piece of graph paper makes everybody panic. But not a hard problem, that one. Once you get over the fact you have to put it on a graph. Because like I said, the 4 side was very obviously the shortest side, even without doing the math to find the square root of 52. Good to do that and check it, but pretty straightforward. Pretty straightforward, guys.